All right. I think we should begin at on the hour, and we have a lot of experts who have to speak as well as a lot of participants. Good afternoon, everybody. Thanks very much and welcome. Thank you as well for joining us for what we hope will be a new and fresh conversation on the topic of air pollution, which is becoming commonplace, but yet solutions remain wanting. This group needs little introduction. You have been experts in the field. You've done some absolutely innovative research on the subject, and I'm not adequately placed to even welcome you, but I'm really honored to be moderating the session. My name is Aarti, for those of us who have not met. I represent GSCC, which is a global climate network and working at the interface of policy and public engagement. Like I said, we have many honorable experts and government functionaries with us, and we're all keen to get going and hear the views and perspectives on all of you on air quality management in the country, and specifically for the project that we are discussing today. I can explain the flow, but before I go further, I'd first like to hand over the floor to Priya Shankar, who's the India Director for the Climate and Environment Program at Bloomberg Philanthropies, and many of you know Priya. Priya, welcome for this, and thanks for taking the time. Could you please introduce today's session, welcome everybody, and set the context before we proceed further?
Thanks, Aarti. On behalf of Bloomberg Philanthropies, I'd like to welcome everyone here today. Thank you so much for joining us. For those of you that don't know us, Bloomberg Philanthropies is a nonprofit foundation set up by Michael Bloomberg, previously mayor of New York City, and currently serving as United Nations Special Envoy for Climate Ambition and Solutions. We support work in 810 cities in 170 countries around the world, and a focus area of our work is air quality. Here in India, we're really honored to have a partnership with the Ministry of Environment, Forest and Climate Change in support of the National Clean Air Program, as part of which, together with technical partners, we're supporting work on air quality in cities, including Patna, Surat, Bangalore, and the Delhi National Capital Region, as well as at the national level. We also support an international network of cities, C40, which has brought together 35 cities to commit to an air quality declaration, and we're delighted that 2 Indian cities are part of this. Air pollution is a major challenge, not just in India, but globally. Air pollution is not only an environmental challenge, but also has implications for public health, quality of life, and economic development. The World Health Organization estimates that 90% of the world's population breathes air that is unhealthy. And in 2016, the World Bank estimated that air pollution cost the global economy $5.7 trillion, or for nearly 4.5% of global GDP. Our founder, Michael Bloomberg, likes to say that you can't manage what you can't measure. And that is a principle he relied on as mayor of New York City. And indeed, when we look at international examples of trying to reduce air pollution, we find that better evidence and data have played a critical role in helping improve air quality. I'd like to share an example from New York City. When Michael Bloomberg was mayor of New York City, he launched Plan NYC, a plan for a greener, greater New York. As part of this plan, improving air quality in the city was a key goal. Working with partners, the city launched the New York Community Air Survey and installed street-level air quality monitors to more accurately pinpoint the levels and sources of pollution. With increased monitoring and data analysis, it was found that just 1% of the city's buildings were causing as much pollution as the city's cars and trucks put together. On the basis of that data, the city banned the dirtiest burning heating fuels and created public-private funding programs to help building owners make the switch to cleaner fuels. In just 5 years, the amount of particulate pollution fell by 23%, and the amount of sulfur dioxide in the air fell by 69%. This and other examples from cities such as Mexico City and London highlight the role that data can play. Yet, over half of the world's countries do not produce any air quality monitoring data. In India, we know that the National Clean Air Program has committed to and has been expanding the monitoring network. Yet, given the size of the country, the density of the population, and challenges of rural as well as urban air pollution, this is a challenging task. While traditionally reference grade monitors have been used for monitoring data, and these remain the gold standard for regulatory monitoring, innovative new technologies that make it possible to capture information about air quality at lower cost and at different spatial scales are emerging. We've been glad to see the leadership of the Maharashtra Pollution Control Board in piloting these technologies and are delighted to partner with MPCB and IIT Kanpur in a first of its kind pilot in India. As part of this pilot, which we'll hear the findings of from Professor Tripathi soon, 40 sensors from 4 different Indian startup companies, Ayurveda Technologies, Oizom Instruments, Personal Air Quality Systems, and Respirer Living Sciences were deployed alongside 15 reference monitors in the Mumbai metropolitan region. In addition to the work that we've supported in Mumbai, we've also supported small sensor deployment in partnership with city governments in Denver, Paris, and London. In London, in the new phase of the Breathe London initiative, which we'll also hear a bit about later today, data from small sensors will be combined with data from regulatory monitors. In London and Paris, data from small sensors has helped mobilize support for and validate the effectiveness of ambitious air quality policies, such as ultra-low emission zones and the pedestrianization of spaces and streets. Data from small sensors has the potential to help complement traditional air quality monitoring systems, help inform the design and evaluate the impact of air pollution policies, and help build support for bold measures by raising public awareness and engaging citizens. While it is so encouraging to see these advances and innovations in monitoring technologies, these are only part of addressing the air pollution problem. It's ultimately how that evidence and data is used, how it leads to effective policies and actions, and wider societal behavior change that will help improve air quality. Given the scale and urgency of the air pollution challenge, both policy action and data availability need to progress side by side, with better evidence leading to more informed policies and effective actions for cleaner air. Thank you all for joining us today, and a big thank you to the Maharashtra Pollution Control Board, IIT Kanpur, and the 4 sensor companies for their collaboration and efforts on this project, as well as to Mr. Kumar, Mr. Srivastav, and all our panelists for joining the discussion, and to Aarti for hosting this panel. Back to you, Aarti.
Thanks very much, Priya, and thanks for explaining what the project is about. As I go further, maybe I can explain what the flow for the session is. We will first have, now we have Sudhir Srivastav, GS Chairman of MPCB, but before I invite you, sir, can I take a minute to also explain what the session will flow like? We will have the presentation of the findings and highlights by Professor Tripathi. And after that, we have the perspectives from the startup as such who have done the installation and will have valuable insights and experiences to share. After we'll break into the panel, which will have perspectives from Kunal Kumarji, Dr. Benjamin Bharat, and Dr. Motkare, as well as Chetan and Professor Tripathi. We will keep about 15 to 20 minutes in the end for an open round of moderated question and answers. But since there will be a lot of information that will flow from now on, may I also request you to keep typing your questions and clarifications that you have in the chat box. We will try and pick them up, and depending on the time in the end, we will also pick up some questions in the end, which the panel will be open to address. I know that there are members from the media who are also present and attending this session. As always, my request to you is that all the speakers here are on record. You're free to pick up what is being said, but at the same time, may I request you to please check back on quotes if you're quoting a panel member specifically. And also some of the data and findings that are being presented is unpublished data. So may I also request you to keep that in mind, and please double check if you're presenting some of the data, graphs, and infographics as such. And the person to check back on all of this will be Professor Tripathi. Please make sure that this is respected, because these are unpublished findings, but we welcome you all to be here. And once again, without further ado, let's start the rest of the proceedings. And may I welcome you, sir, Sudhir Srivastav, Chairman of Maharashtra Pollution Control Board, who's been an extremely progressive chairman, and under your leadership, sir, there is massive progress that's being made at the PCB. So it will be nice to hear your views on how do you think this method of innovation and technology can really bring about change in the air quality management system, and how this translates to other parts of the country, the experience that MPCB has had. Over to you, sir.
Thank you, Aarti. And let me first of all welcome and also thank Dr. Tripathi, Priyaji, and other panelists, and also the members of the audience. Am I audible properly? Yeah. Okay. Good. Yes. So it's a great pleasure to be a part of this webinar. We have many environmental challenges. And one of the big challenges, which is air pollution, that is very pervasive and also very intrusive, because we are immersed in air. And there's no way of escaping air pollution. You breathe about 11,000 liters of air every day. And you can buy bottled water. But I think we have not hopefully reach the stage where we would need to buy bottled air. And we have seen how difficult it can be, even in a small measure. We just had that experience. So bottled air, hopefully we won't ever reach there. Now, when we are faced with a problem, actually, and we realize we have a problem, the first thing to do is to measure the problem. And Government of India, CPCB, along with the various boards, started the National Air Monitoring Program. And that has been ongoing for a few years now. In Maharashtra, for example, we have close to 100 stations. I think about 85 of them are manual, and about 15, I think 18 is the right number, 18 are continuous ambient air quality monitoring stations. Now, obviously, our state being about 300,000 square kilometers, this is not a very, this is a very patchy, sparse network. And if you were to look at air quality in a more meaningful manner in the local context and even in the hyper-local context, then we need a dense network. And actually, that has been one of the programs that we have taken. But we do realize that the cost of regulatory grade sensors is really prohibitive for deployment on a very extensive scale. I mean, whenever you're looking at use of monitoring equipment, there is always a trade-off that comes to your mind. I mean, am I going to spend all the money that I have only on measurement, or am I going to do something about mitigation as well? So you really are looking at solutions which enable you to monitor air quality without actually spending a phenomenal amount of money on that. And I think the world over, this is being attempted, and Priyaji just in a talk actually gave some examples, and everywhere this effort is going on to bring in low-cost sensors to be able to monitor air quality in a dense network. Now, I'm very happy actually to say that while we have been grappling with this problem, the civil society at large, very bright young people who are enterprising also have taken upon themselves to solve this problem. So it's not as if only government agencies are trying to solve this problem. And that is where we have these startups set up by very bright, intelligent people who actually are trying to solve this problem. However, when we look at any measuring instrument, now there are many academic experts out here they would agree with me that you're looking for certain qualities in that. The first one is that you are looking at accuracy. It should actually kind of measure what you're supposed to be measuring. It should be precise. Then there is an issue of sensitivity, and there's an issue of resolution. So these are four qualities which one would look for in any measuring equipment, in any monitor. And in addition to that, if we have like, if the response of the monitor is linear, or especially we want the monitor to be stable across seasons, across different ambient conditions. So these are some of the qualities that we need. And when we look at the reference grade sensors, monitors, and the low cost sensors, then we have two entirely different types of technologies being used. When you talk of reference method, actually, when you talk of reference method, then the reference method which is accepted the world over is the gravimetric method. That is, you actually collect the, let the air pass through a filter and collect the dust and actually measure the weight. But then you have what are called reference grade equivalent methods. So you have a beta attenuation monitor, or you have what is popularly known as TEOM. So these are some of the reference grade monitors. Now, each of these is pretty costly, and you really can't, as I said earlier, you won't be able to actually have a very dense network of them. On the other hand, actually, if you were to look at sensors, they work on some different principles. So the sensors that we have, they work on laser scattering. And these sensors actually, as I understand, I'm sure the panelists and the other colleagues, they would elaborate on that, is that they work in terms of counting the number of particles. And then they use internal algorithms inbuilt into the sensor to convert the sensor signal into a meaningful measure of particulate pollution, which is like we are looking at PM 2.5 or PM10. So the two actually have to correlate well with each other for the sensors to give us some data which is comparable to what data we get from the reference grade monitors. We actually looked at many deployments. I am seeing Kunal here. I think Kunal was in Pune when a lot of deployment took place of sensors. And what we were trying to see is how well they correlate with each other. And that is where actually I'm really very thankful to Professor Tripathi, where he offered to take up the study on our behalf. And we were able to actually do a pretty widespread study with 10 locations in Mumbai and close to 40 sensors from 4 different entities. And the period of this study is also extensive because it covers almost all the relevant months of the year, starting from post-monsoon going up to early summer. I think it's 7 months of continuous data. And this actually enables us to compare the sensor data with reference monitors data over an extensive period of time and in very different ambient conditions. And I think that's going to be pretty valuable. Beyond that, as Professor Tripathi is going to explain when he speaks, is that Professor Tripathi and his team actually used machine learning tools to actually improve upon our ability to correlate the sensor data with the reference data. So they have actually run certain additional algorithms beyond what is already inbuilt into the sensor and try and see how good a fit we can get between the sensor data and the reference monitor data. So it's been a pretty interesting experience. It's the first of its kind in terms of its scope and in terms of the time frame. In India, I think there have been a few studies which I've been on and off sharing with Professor Tripathi, and I saw a couple of studies in Europe especially, which I think 1 or 2 of them are as extensive as ours, perhaps. perhaps not, because they have possibly looked at only 1 or 2 locations. So we have an extensive data, good data, and what I think is that we will be able to do 2 things with this. One is that the entrepreneurs who are actually trying to bring this technology into the mainstream, they would have very good data with which they can actually try and work out on their internal algorithms better, so that what data the sensor, the primary sensor signal, which is usually some volts or millivolts or microvolts, that is converted into particulate measurement, that actually becomes more accurate without the need for an add-on machine learning algorithm. That's one bit. And the second and more important thing, I think, is that this kind of study is going to actually give us a very objective method of assessing the bounds of confidence that we should put on sensor data. It's a very, very objective method of trying to bring those bounds. And when we actually look at the deployment and rollout of sensors, then we know exactly what kind of confidence we should have in this data. So I'm very, very happy that this particular study actually we have been able to carry out. It brings the subject somewhat into the forefront in terms of our ability to have a dense monitoring network. And I am, of course, especially thankful to Bloomberg for having partnered with us in this endeavor. And with these introductory remarks, I will stop at this point of time and hand over the proceedings back to Aarti. Aarti, thank you very much.
Thanks very much, sir. It's always a pleasure to listen to you. Now I've figured out whether we are talking about renewable energy or electric vehicles or air quality management in India, there is always useful insights that you have to share right at the beginning, and thanks very much for that. I know that there are a lot of participants here, and some of the participants are extremely technically qualified. I'm also conscious that there are some experts there, but there are media representatives and some of us who don't understand all the technical details. So before I hand over to Professor Tripathi, if I can quickly just summarize what you said, the way I understood is that the project is nearly the most extensive in the world, but you can clarify, which itself I think is quite a remarkable and significant thing as an innovative project of the first kind in the country. And I think you also very clearly said something which basically means let's not make perfect the enemy of good. We have good data. We can work with it. Let's not just wait to get all the regulatory grade monitors because of the cost implications and the fact that it comes at a very different and reduced cost, but still does the work. And I'll let Professor Tripathi talk in detail, but the matter about machine learning, the way I understood is that it's still going to minimize the mismatch between what is best and what this one gives. So that's a huge list where the applicability of this can be, but maybe that's more to discuss in the other panel. But like I said, sounds really promising already the way Priya and you have described, and it looks like this brings together all the desirable attributes to inform the right policy measures on air quality management in India. But I have spoken more than what I meant to, and I must hand it over now to Professor Tripathi, who's the lead on this project and one of the best brains on air quality. And the floor is yours, Prof, to just take us through the findings and the highlights. And you will have about 20 minutes. I will feel bad to intervene, but I will try to if time exceeds.
Yeah, thank you, Aarti. I believe my slides are visible and I'm clearly audible, right? Yeah.
Absolutely. Please go on.
So, good afternoon, Srivastav ji. Of course, I'm very grateful to him for giving us this opportunity to do this work. Without MPCB, of course, this work couldn't have been possible. I also must acknowledge the support given by Dr. Modgare, who is here, who will be on the panel with me. I am very thankful for Mr. Kunal to taking time out and listen to what's going on here. And thanks to, of course, Bloomberg, which has supported this project also. So let me start. Of course, this work is about technical assessment of sensors based PM 2.5 and PM10 monitoring. This work is done with my colleague, Professor Bipul Arora of Electrical Engineering at IIT Kanpur. And certainly, I again reiterate my gratitude to Maharashtra Pollution Board as well as Bloomberg Philanthropies for supporting this work. So basically, I will talk about objective of this study. What is the evaluation criterion we have used here? How did we selected startups, sensor types, etc. I will give some brief idea about data set and show some sample diagonal plots from government monitors and sensors. And then what is the motivation behind this work? And the primary motivation is to improve upon the sensed data by sensors so that it can become comparable to government monitor data, comparable, if not exactly same. And for that, we'll show you the power of machine learning, to say like that, and then some conclusion and the future work. So basically, the objective of this work is to calibrate sensors based PM 2.5 and PM10 data. And we also want to see or ensure that sensors are reliable. This is a 2 years long project. And as Srivastav mentioned that the deployment was from November 1st to May 31st, so exactly for 7 months. And the evaluation criteria, what we were looking for, are the sensors should give high frequency, that is every minute data, 2.5 and 10. The data must be pre-calibrated, as Mr. Srivastav already pointed out. And these devices should be solar powered, or energy-wise, they should be self-sufficient. And then in terms of statistical measure, we are looking for a correlation coefficient R square greater than 0.85 and a mean absolute percentage error within 15%. And then of course, we are also looking for some documented evidences which these startup or the sensors already have published about them. So as was pointed out, there are 4 startups. The names are here. We already have that has been mentioned. And shortlisting criteria was that they need to be startup. The units need to be developed in the country, and they should have some prior experience of working with government agencies. So now henceforth, the result I will show will be a blind result. So basically now the 4 startups, we are just going to show their results as A, B, C, and D. And out of 4, 2 of them have similar sensors, and then 2 of them have different. So altogether, within 4, there are 3 different sensors they have used, and all of them work on laser scattering. So this is what on the left, you have the map of Mumbai metropolitan. And what you see here on the red dots, which are 5, all 4 units were deployed. So basically 20 units there. And then remaining blue are 10 additional sites where 2 startups, A and B, deployed the sensor. So altogether, actually 15 sites were there where 40 sensors were deployed for 7 months. You could probably go through, if you wish, that an op-ed with Bipul I wrote yesterday, and that was published in Hindustan Times. So now I will tell you about the data set. So we have divided the data set into 2 periods. One is basically till January, and then from February to May. The first one we call season 1, because there is a great seasonality. And from our prior work on sensors calibration, we know that with seasons, aerosols composition changes, and that also could change the calibration factor. And that is why we are attempting this problem by grouping it into 2 seasons. And then we are trying to get 2 different calibration model, first for season 1, and then we'll attempt for season 2, and then we'll try to have a grand unified model for the 2 seasons. This table, of course, is just a snippet of all the data we have just shown here from 6 locations for different months, just to give you an idea that what kind of PM 2.5 levels we are seeing in Mumbai during those times. You see there are occasionally very, very high. I mean, on a monthly average, In Ville Parle, Kalyan, Worli, you see PM2.5 as high as 80, 90, or even exceeding 100, but there are also some lean periods. If you see the data we have used here for developing the calibration and looking to get deeper insight is hourly data. So from minute-wise data, we average it over hour, and that's the data we have used here. Again, you see this table gives the 5 locations where all startups have their unit deployed. There is season 1 and there is season 2. The first column gives you the government monitor, total number of hourly data. The numbers here are hourly data. And what you see in season 1, generally speaking, at every location from every startup, we had about 2,000 plus data points. That's a lot. That's a large data point, as Srivastav already mentioned before. And this is slightly lesser than season 2, where the number of hourly data points exceeded 2,500, because some of the sensors were deployed by middle of November. You know, last year, how the situation was. Getting on the ground was difficult, and therefore, of course, we see a small difference, but regardless, we have actually, I must say that it's a gold mine of data here. So this is first we show what is the uptime. So we always had some concern that sensors do not give sufficient data, that is from sensing to storing and then transmitting. At every step, there is data loss. But what we have seen here now that it's an uptime. We define it on time divided by on time plus off time is uptime. And this is given for the government monitor is the first bar, and then the 4 startup ABCD. And what you generally see that all 4 sensors actually have higher uptime than the government monitor. And generally they are reaching about 95% plus. So that's a very good news, I would say, that sensors have kind of come a long way since I started working with them a few years back, and the uptime is increasing. The second thing is that they required very little assistance. And you could understand that except one startup, 3 are based out of Mumbai, Bangalore, Ahmedabad, and Delhi. So there's no way that they could get ground support. So with very little support, the sensors were running. So they are, in true sense, they are becoming autonomous. This is just to give you an idea about the diurnal variation, that how the sensors capture the day-night variation of PM2.5 that is shown on y-axis. X-axis is the time of the day. And you have the black line everywhere will be the reference curve. And 4 startup measured sensors are basically by 4 different colors. Broadly, what you see at Nerul, that the trends are captured quite well. And the government monitor data lies somewhere within these sensors monitor data. Particularly, if you look, there are 2 peaks we see in urban areas. One is just before 10 a.m. when there is a cooking and rush hours, another evening time just after 8 or 9. And these 2 peaks are by and large captured by all sensors. And just to show you maybe just 1 or 2 more locations, you see at Mahape, again, very similar kind of trends observed by 4 sensors as well as by the government monitor data. You see that is even better observed at Ville Parle. So all in all, the diurnal variation is quite well captured here. Now I would come to the motivation, that our primary motivation is to improve the data which is measured by the sensors by applying some kind of calibration models. And we need to understand that the models we first would develop are not specific. They are very specific for device and location, and we want to improve upon that. So we start with device and location specific model, and then we try to have a more generic model. So in the first phase, what we call is a development of a base model. That is when a sensor or unit is deployed side by side with a reference monitor, and you have large data, you train it and test it. That is the base model, what we call. And then we try to port this model in the second phase, what we call a target site. A target site where you do not have long deployment. So for example, if you have a mobile based government monitor and which is deployed at a target site only for few days, you have little data. But if you have already a base model and you have ported it well, that model could actually start or could be applied to the sensor, to the target site, and that can also give some very good result. And that is what I'll be showing here in the next slides. So just in the cartoon, briefly, the way it looks, you have phase one, you have the source data, the data which is measured by CAQMS and sensor. You derive features from them, and then you develop a base model. You first prepare it, and then you, of course, test it. In the phase two, you actually transfer the model. So now we call it here, this first step is the target data. And then rest of the features are same. Of course, the base model now is converted into a adopted model. So details are, of course, in the slide. These are mathematical details, so I will not go into them. So first, we developed the base model, and as you see, we have tried a variety of machine learning models, starting with very simple ones, linear regression, and progressively trying more complex one. And most of the work, what I'm going to show, result I'm going to show, is based on the dense neural network, that is a DNN model. We have tried the base model with 8 weeks of data, that is for training, and the 2 weeks is for testing. So it is, here is what we mean by base features and derived features. So what you see, the base features are the primary variable that are measured, PM2.5, PM10, relative humidity and temperature. And then what you see, derived features, like we do some cosine or sine just to get the periodicity right. Then many times, you know, the PM at time t depends on the previous time step. So that's why you see in the fourth row, there is t-1, t-2, and then there are some non-linear features. So that is the way the model is developed. Now here is the summary result. So these are average error, and what you see, uncalibrated and calibrated errors are given with respect to the government monitor for 4 startup. If I have to just summarize it, what you see here is that uncalibrated sensors for 3 are less than 25%. And once we apply the base calibration, it actually comes down below 25%. And I said that these results are still for 1 season, but they are quite robust, because if you look, the total number of data points which have entered into doing this analysis is 32,000 data points. And that's by large, to my knowledge, is the largest number or largest sample that has been used in such kind of experiment. Now here is what again is a summary R square. So again, for 4 startup, R square, you know, gives the idea that how well the sensors are capturing the trend measured by the government monitor, which we think is a true measurement here. And again, what you see that basically 2 sensors have high R square going above 0.75, 0.75 or 0.8. And these are calculated for basically 4. There was one site where there was some problem with the government monitor, so we have excluded it from the analysis. And this only shows that when we apply calibration, how the results improve. So what we see that results dramatically improve for actually 3, but for 1, actually it does not improve so much. This is just to show the time series, and there are 3 curves here. If you see on the y-axis, you have PM2.5. On X, you have different dates, so about few weeks of data shown here. The black line is again the reference, the true value. Red is uncalibrated. So you see there are large differences between uncalibrated sensor data for sensor A and the true value. But once we apply the base calibration, you see how the blue line comes very close in terms of absolute value and the trend measured by the reference monitor. So just to show you that this is not specific for one station or one sensor. If you look for the same sensor at Mahape, you again see that the blue curve comes closer after application of calibration model. If I see For sensor B for Nerul, you again see that after application of the calibration on red curve, the blue curve comes very close to the black, which is the true value here. Okay. And if I show it for again sensor C and particularly also for sensor D, we see that a similar kind of result, consistent results have been shown all along, and it's the same model that has been applied. That is the DNN model. So now, once this part was established, as I mentioned before, that we have now developed this model, which is a sensor and location specific. Now we want to port this model to a different site, which we call as a target site, and then we want to apply it to the new sensor. So here, the results we are going to show is to use the data for developing the base model is at airport, and then we are going to apply it Mahape, Nerul, and Vile-Parle. That's what I'm going to show it here. And this is what you see, that for different sensors, you see uncalibrated values when you don't apply this adopted model calibration. There is a very high error. Particularly, you see that for 3 sensors, the uncalibrated values are very high, going up to factor up to 200%. But the moment you apply this model, the error can drop up to 20 to 15%. And that is a good achievement from this work, that not only we were able to develop a base model, of course, that showed a very good, robust result, consistent across sites, but we were able to take that base model, tweak that, and apply it to a target site. And we could see that it can give you a very good result also. And this is, of course, the R square. And you see again that R square for 2 startup is more than, or 2 sensors is more than 0.7. For, in fact, 1 is more than 0.85. And then for 2, actually, it's not so good. And of course, a similar time series I'm again showing here, that once you apply the calibration model, the adopted model, so that is the model developed at airport, and it is applied at Mahape for sensor A, and you see similar trend what we showed earlier, that the red curve is brought closer to the black curve, that is the blue. And that is what consistently, if you look at this few weeks of data, and this, if we want to see a couple of more slides, this clearly shows, and this is kind of a trend we have seen for other stations as well. So I will not go into the details of that. So from this, let's say preliminary analysis, because a lot of analysis is going on, but certainly first part, the phase 1, we are quite confident given the data, the signals we have. I want to conclude here that certainly large number of data we have got, high quality, large number of data. The sensors could run today, indigenous sensors, with very little or no manual assistance. I showed that uptime is very high, and it is more than 95%. When we apply the calibration, base calibration, the error could come as down as 15, sometimes it is even 10%. R square has gone above 0.8. We have also seen that if we add some intuitive derived feature, the model performance can improve. And remember that one cannot separate the machine learning and artificial intelligence from the basic sensing, that is the sensor. So it's actually is a very, very intertwined thing. Now, once we applied the base calibration model to the new places, that is the target, we found that error can be as low as 11%, and again, R square can be very high. And this is a very positive thing, because certainly we will not have the luxury to have long side-by-side deployment for all sensors. We can have some deployment, co-deployment, but after that, we'll have to apply the developed models to new locations by improving those calibration models. And in that way, this is a very novel result, and that what we are getting here. And that certainly will help us in maintaining a dense air quality monitoring network and a reliable network in future. So this is one paper. I just want to show that this is almost a done paper. We are ready to submit it to a very good journal of IEEE. with my colleagues from IIT Kanpur and MPCB. And one thing which already has started is that, as we mentioned, that we want to actually develop a much generalized data, which is not specific to the season or source, etc. So that is what is our next target, and we have already started working on that. So I will stop it here, and I'll be very happy to take any questions. Thank you very much.
Thanks very much, Prof. And I think the bottom line that you said is it's not always possible to co-locate, but it's basically to create a model that can be transferable to other locations as well. As we move into the second section of our discussion today, I think that's what we would like to hear from all the 4 startups, the perspective that they had in not just doing this pilot as a pilot, but also how this seed could be scaled up further and what the implications of that could be. I will pause, but before welcoming the 4 colleagues who lead all these startups and have been involved in the project, very happy to pass on the floor to you. There is Ronak Sutaria, who's the CEO of Respirr Living Sciences, Namita Gupta, who heads Ayurveda Technologies, A. Vaidyanathan from Personal Air Quality Systems, and I.N. Karmakar from Oizom Instruments. Maybe in, we can follow any order, but I.N. Karmakar, maybe you can start.
Thank you, Aarti, for this opportunity. It always helps to start with an alphabet A, so I always get that preference. So I'll just take this moment and share a little presentation that we can just to help us come to the point that we are all discussing here. So just to give you a context of the low-cost sensor, I'm really thankful for this opportunity that all of us have been given from MPCB, Bloomberg, and IIT Kanpur. To give a context of what we have been doing so far and where the co-location study actually matters to all of us, we came up with this idea of the low-cost sensors, which a wonderful pretext has been set by Chairman Sir himself, Mr. Srivastav, where why we came to the need of such kind of a system. And when we integrated all these parameters, we could find so many applications that came into the picture, where they were regulatory or non-regulatory. And we could so far come to around 500 locations in the world where we could identify these locations which they were deprived of any kind of measurable value. I think Priya was mentioning in the beginning that what we cannot measure, we cannot act upon, right? So this is where we found out the importance of such systems and how people have been benefited. And then came the most important part of such kind of location calibration. So beyond what we were doing in our laboratories with zero gases as well as fan gases for maybe particulate matter and gaseous parameters, we could find that such kind of studies help ensuring the accuracy. And we started participating in a more and more number of such studies globally. So there were many agencies in the world which conduct such kind of studies. But the beauty of this study, I'm going to come to why this became such an important one that we participated. So the previous ones that we did, one was with MPCB in the last couple of years, and then another one that we did was with HORIBA. And we got some fair good results when it came to participate in such studies. So the idea is that we do such studies in more and more locations because each and every climate makes the sensor work differently, and that also helps us learn about those kind of areas. So we participate in maybe cold climatic conditions like Germany, or maybe humid conditions in maybe Kerala and so on. So Mumbai was a very specific location that helped us identify such kind of a climate. And the important part was the length, the duration of the study. I think very less number of studies have such kind of an elongated duration. So that helps in capturing the seasonal variations and make the data helpful for people like us as well as agencies like or maybe universities. So the takeaways that I was saying, as I said, is one of a kind study in India that, and I'm very thankful for Maharashtra Pollution Control Board, IIT Kanpur, and Bloomberg to actually come up and curate such kind of study and help get people like us involved in this, participate. And unfortunately, we could only participate in 5 of such locations, but in the future, we would like to see such kind of studies taken in India. We also got good support from BCB and IIT Kanpur, and we could get some insights on where we could improve upon, or there were some locations that we had good results, some where there were some things to be done in the future. But the most important thing is the scope of machine learning and artificial intelligence. Last year, we started working on it, and it is very good to see that IIT Kanpur is also building the models and working on this. So that kind of builds our confidence in generating such models. Lastly, before I conclude and hand it over to my other colleagues from a different startup, I thank the Maharashtra Pollution Control Board, IIT Kanpur, and Bloomberg. But very importantly, this phase was at the peak of COVID in India. So there were a lot of challenges, whether it be installation, whether it be upkeeping the devices. So the engineers who helped us on site to do this. So just a special thanks. We often miss out on thanking them. This was a challenging time to participate in a study. We were in Ahmedabad, and we had to walk around with Mumbai. So yeah, so with this, I can conclude my part, and I hope that we can come up with more and more studies where startups like us can contribute and learn. And if we have a central facility or maybe multiple facilities around in India, which is right now very limited to, so I think more and more people would love to come and join in these kind of studies. So thank you from me.
Thanks very much. And before we proceed, I just also noticed that Shri Nareshpal Gangwarji is with us, who's the Joint Secretary at the Ministry of Environment, Forest and Climate Change, and also the Chairman of Central Pollution Control Board. Sir, welcome to you. Thanks for joining us. We had opening remarks from you, but if you do not mind, we will continue with the presentations from the startups. And as we bring together the panel in about 10 minutes, I will bring you back in, but thanks very much for joining. Let's keep going. Sorry, I've lost the alphabetical order, but Mr. A. Vaidyanathan, would you like to, in the spirit of being chronologically correct? Your mute button is still on.
Okay, thank you. I'll just share 2 slides. In the first instance, let me thank the organizers, MPSCB, IIT Kanpur, Bloomberg. I just want to share our experience. I hope you're able to see the slide. Okay. I hope you're able to see the slides, please.
Yes, please.
Yeah, thank you. Yeah, we are from Personal Air Quality Systems, PACS, as it's called. Personal air quality has become much more relevant and critical now with COVID. Let me talk about the technology that we are using to try and ensure get some accurate data. We call it a context-aware calibration model. As you see it on the right side, we sense data, filter out the noise from the sensors, the data that we get, we curate it at the back end, and over the air, we calibrate. That's our model, because at the edge, the devices are not intelligent enough. Some bit of handholding from the cloud, I believe, is required. So the objective of the project or our sensor is to get accurate data. Second is to manage the data limitations of these sensors, figure out when they phase out, when you have to change it and things like that, and ensure that we manage it in a cost-effective manner. The EPA recommended protocol of lab calibration concurrently done along with the field calibration enables us to get higher accuracy. And of course, we are able to do this. We have installations across in multiple places, and we'll be able to proudly talk about high R squared value, as you saw in the presentation also, startup D. Now, if I may say, like, we have sensors across 15 cities in the country. I won't get into the length and breadth of it. We have been able to talk of high level of accuracy of the data. Our sensors measure not only PM2.5, all the criteria pollutants in terms of air quality index, UVA, UVB, and also the noise part of it, because noise is a pollutant. So we have installations in 15 cities. But from my experience, if I may something, sir, I realize there are MOEFCC and also MOUD personnel there. So with permission, if I may say, sir, If only we were given little permission to co-locate with any of the state or central pollution control boards, we would have done a fantastic project all through last 4 years. In Jaipur, we have data for the last 5 years. And when we are able to co-locate, model, and learn continuously through ML, we have been able to talk of consistent accuracy above 80%. Similarly in Vizag, but in several other smart cities projects, we have not been able to get permission to co-locate it. If only, if there are 4 startups here, if I may make a sentence, sir, with the new generation sensors, we believe we can get accurate, meaningful, actionable data. If you kindly allow us to co-locate it with one of the SPCB regulatory class equipment, we have the data points here, as you can see. I've just openly said here Jaipur accuracy, and when I could not get a co-location when it is 15 kilometers, by our model, we've been able to talk about accuracy of 60%, but by continuous learning, we are confident of going up to 0.8, 0.9. This is for the PM 2.5 and PM 10. As far as ozone, NO2, SO2, and also CO, we have been able to get reasonably good accuracies. We'll be happy to collaborate with any of the institutions. We have 5 years of data in various cities. We'll be absolutely delighted and happy to participate in the projects. Once again, thank you all. I think we as entrepreneurs, we are trying to bring new generation sensors, low-cost solutions, technologically effective solutions to the country. We would seek the support of all the institutions so that we are able to do it. India has got the most complex climate environments that we can talk of. I believe we will be able to get the best models and take the solution to the world. That I'm very, very confident. Thank you all.
Thanks very much. I know we are inching close. We have another panel as well. So let's keep going. Namita, can I please invite you?
Hi, I'll just share my screen. Yes, can you see my screen? So hi, my name is Namita. I am the founder of Ayurveda, and we have been working now in this space for the last 6 years. We've done several previous co-locations, with BAMs in different locations with, Dr. Joshua Apte's BAM, as well as with the US Embassy and others. And then we also work with the Gurgaon Municipal Department, where we've done some co-locations. But this is actually the first time that we've done such a massive co-location with 15 BAMs at the same time. And, I can't be more grateful to MPCB, Bloomberg, as well as Dr. Professor S.N. Tripathi to give us this opportunity to do this. This was actually a huge, learning experience for us as a startup. We managed to get almost 100% uptime, so that was really good. We were doing real-time calibrations, all our sensors, and we were getting pretty good, R2s and errors. So, in the past 6 years, we have been investing, in high uptime, managing humidity, really working on real-time remote calibration systems where, and this is something we're actually working with GMDA on, where we've co-located our sensors with government BAMs. And then we have created a network of low-cost sensors around them. And then we use the BAMs, to real-time calibrate our sensors and push that calibration out to the network. So this actually allows us to, calibrate our sensors seasonally on a real-time basis and create networks which can be calibrated over a period of time. In terms of sort of learnings, it was a pleasure to see Dr. S.N. Tripathi's work. We use a lot of sort of multilinear models for calibration, but clearly there's a huge opportunity for using ML and AI to improve calibrations, with that. So we're really looking forward to working with Dr. Tripathi on that. Right now, a lot of the calibrations that IIT Kanpur is doing are offline. We believe there's an opportunity to actually do these calibrations real time. So this is somewhere we want to partner with IIT Kanpur to start doing these calibrations real time. And then, also if we do this in a way where we do a geographic co-location at the same time, then there's an opportunity to actually do real time seasonal calibrations as well. And we truly believe that, this can really get us to the vision where we can expand the air quality networks in different cities, where you have, maybe one or few or two BAMs, and then you can create a low-cost network around it, which uses the BAM co-location to constantly calibrate the sensors in the network. So really excited, and I wanted to thank Dr. Tripathi and MPCB and Bloomberg again for giving us this opportunity. It was a huge learning experience for us, and we believe that this was a great step in moving us forward in the low-cost network dream in India. Thank you.
Thanks, Namita. And given by the questions in the question and answer box, there's clearly a lot of interest in how all these startups have executed the project. And please do take a look at the Q&A as well. Ronak, we worked together for the last many years. You've been quite at the forefront of bringing tech and innovation in the air quality space. Over to you and your journey with this project.
Yes. Hi, Aarti. Thanks so much. Thank you for, thanks to MPCB, Chairman Srivastav, Dr. Mudgare, and Dr. Tripathi from IIT Kanpur for putting this project together, and for Bloomberg for supporting this activity. I'm Ronak Sutaria, founder and CEO of Respiro Living Sciences. Our journey actually in the space of air quality monitoring started in 2015. When we started building the first set of air quality monitors as a non-profit initiative for a data journalism project. We then initially got support from Shakti Foundation and IIT Kanpur and Duke University to take this work forward and kind of build the whole scientific validation aspect of this work. So a lot of data dissemination work that we started doing began in 2016. And in 2017 and 18, we started doing a deep dive when our work with IIT Kanpur really kind of took off, and we got support from DST and as a project from IUSSTF. And then we got a collaboration with Microsoft Research also going on this work. In 2019 and 2020, of course, 2020 has been a COVID year, but in 2019, we started doing out some global projects in US, Sweden, South Africa, and other countries. There is a patent that we filed, and then 2021 actually has been a critical year. Of course, the MPCB project has been quite fundamental to our work, and a couple of other projects that we are doing with central government agencies. We've got some projects going on around oxygen analyzers also. Coming to the specific MPCB project and the perspectives from us, really speaking, I mean, like some of you may know, we've been in the space for the last 5 years. We've been doing a lot of this work. I think the learnings we've had from this engagement, with really good organizations has been that, this work has been a very good, it has given us significant insights. And I think one of the perspectives we can share is that this study should extend further for 6 months. We've been getting a lot of interest from, of course, PM2.5 and PM10 are fundamental pollutants, but NOx, SO2, ozone, and other gas pollutants have also been equally critical. And we feel that the study should be extended. And based on the results seen so far, I think it's a good time now that this kind of a network rolls out across the entire state of Maharashtra. And I think the one main takeaway message that I would like to put here is that technology really is just 50% of the work that is done. The remaining 50% is taking this data, giving it that last mile delivery of this data to citizens. And we feel that this work of taking this data and making sure that citizens get access to it is as critical as building the technology. Of course, the data accuracy, all those aspects are critical. And our submission would be that India really needs neighborhood level air quality data, and regulatory monitors are enabling building of sensor networks. But really speaking, citizens need access to data from their 1 kilometer radius. We are seeing a number of projects going on across the world where sources of pollution are being very closely analyzed, and their impact on citizens is being evaluated right down to 50 meters and 100 meters. So, Breathe London is a classic example. Priya will talk about it. Bloomberg has been part of it. And a number of other studies in the US have found that right up to 100 meters, you can evaluate how the pollution is being dispersed. Ultimately, cost, of course, has been analyzed. I mean, we talked about, but, literally in a few crores, you can roll out a dense network, which in terms of the regulatory grade, you need tens of crores. So I think the case is pretty clear on, what needs to be done. Accuracy and precision, of course, a lot of the experts have spoken. So I've not shared a whole lot, but we really would like to make a submission that India needs this, the time for this is kind of now. So that's pretty much all from my end.
Thanks very much, Ronak. I think you summed it also on behalf of the discussion so far, that this is a fairly technical discussion, and the fact that this can be applied elsewhere to the country when, we struggle so much with air quality management, and how Priya started with the famous statement that if you can't measure it, you can't improve it. I think all is indeed falling in line. I see, we have Kunal Kumarji, who I would have wanted to invite now, but at the same time, I also still again wanted to check if Mr. Gangwar was still there, because he was supposed to give the opening address. Sir, are you around and can you hear me? If not, then maybe Gunjan, could you share screen for a moment? And I would like us to just for a moment go through the notes that Mr. Gangwar has shared, and his views on this project, the applicability of this to other air quality measures in the country, and how, as chairman CPCB, he does feel that there is a lot of scope for alternative low-cost technology, which will supplement the conventional technology that we have been using. Sorry that the font is really little, but basically, this is a congratulatory note, so to speak. And the second last point indeed says that the National Physical Laboratory has been put out as, and will be promoting indigenous instruments as well as Make in India, and start to certify the monitors in India very soon, which I think is really a good sign of how things will be going. Thanks very much again for sending us. It could be shared if you all can't read it, but I will keep moving. And we are 7 minutes past 4. We have time till about 4:30. The last part of the session was a panel discussion, and that's how it will be, for which we have Mr. Kunal Kumar, who's the mission director of the very important Smart Cities mission, and himself has been a very proactive bureaucrat involved in many of the ventures. Thanks very much, Mr. Kunal Kumar, for joining us today. Like I said in the panel, we will also have experts who have been involved in this project, and some of our other partners who have looked at the air quality situation from across various angles. So we have Dr. Motkare, who's the Joint Director of the Maharashtra Pollution Control Board. Those of you who have worked in Mumbai and in Maharashtra know that he knows little introduction and is very famous for his initiatives and progressive actions. We also have Chetan Bhattacharjee. Chetan is the Senior Managing Editor at NDTV, but is also an air quality campaigner and very actively involved in the campaign from at least the last 5 years that we've been working on it. Thanks, Chetan, for joining in, and look forward to your insights. We have Dr. Benjamin Barat, who's the Deputy Director of the Environment Research Group at Imperial College London, and will have some insights to air quality monitoring network and the implications that it had and how it all started. Thanks very much, Benjamin, for joining us, and I will come to you in a moment. So let me start with you, Mr. Kunal Kumar. I mean, there is lots that can be said on smart cities. The only thing that I want to say is that smart cities is a mission really, which is about good quality of life and with the intervention of tech. So, that umbrella sentence in a way just encapsulates everything that we've been speaking on the last 1 hour. How do you see this monitoring network and the applicability of it with respect to, your view on the air management across cities in the country, and what do you think is the transferability of this project?
Thank you, Aarti, and thank you, Bloomberg and Professor Tripathi, IIT Kanpur, all the 4 startups. Of course, my senior and mentor, Srivastav sir from MPCB in Maharashtra, and all the dignitaries who are available on the panel. I'll be very short. I understand it's many people and very few minutes. I'll try to be succinct. I think the fundamental problem I see in at this field, and I've been working in this field for the last about 13 years, about 8.5 years in cities, and now about sort of three plus years in Delhi. I think it's really about who builds the cat, because ultimately, as you say, you do what you measure, but who does it is the big question that our cities are grappling with. Is it the pollution control boards? Is it the municipal corporations? Is it the district collectors? Is it the health departments? And so who finally is responsible for improving climate in our cities? And that's one area where, look, I'm not using this as a criticism, but as a forum, as a platform where I think we should initiate this dialogue about how we get climate governance right. And so that, we have a meaningful action-oriented program rather than just doing good measurement and then stopping at it, or even not doing that much. So that's the first point I have to make, which is related to creating this belief in the system that we can actually do it. And given a concerted effort, we can really change the way we are at the moment to a better quality of air quality and life. So we started, looking at it, and we conceptualized the Climate Smart Cities framework. And we said within the Smart Cities program, let's have a dedicated program for Climate Smart Cities. But there's essentially 3 verticals in which we are working on the climate in the Smart City space. One, as you said, was about livability. The second is about improving economic ability of cities. Third is about sustainability. If these 3 don't go together, you're really missing out on some major important issues in the city. So the Climate Smart Cities program, which was launched 2 years back, in fact, we would be very soon, certainly within the next 15 days or a month, release a ranking of all our 100 cities, as well as most of the cities which are more than 500,000 in population, as to how they are doing on climate sensitive development, climate preparedness. And this will be on 5 verticals. One is about water, the second is about waste, third is about air quality and mobility, fourth is about energy and green buildings, and the fifth is about urban planning and biodiversity. So you would then get a fair assessment, and that's about getting a lot of data from various sources and trying to come out with a mirror where we can reflect upon as to which cities are doing better, what are the best practices, and create a belief in the system that if this city can do it, then why can't we do it? So that's how we've tried to precipitate this issue regarding getting a cogent and coherent action in cities together. So it's about bringing the city on one platform and say, look, you're doing this, and these parameters, and these are the agencies which need to come together. And we actually come out with detailed city reports so that the city can actually garner action around it, and garner action around both public and private partners. I think the key initiative that we are looking forward to is the National Mission on Clean Air. That has the potential to actually galvanize further action and support the Climate Smart Cities work that we have started. But that's fundamentally for the cities that we are working in. Essentially, the National Mission on Clean Air should elaborate that and deepen that over a larger part of the country. Of course, it's going to be specifically located in some cities, which are the bigger cities and the non-attainment cities. But I hope that the learnings from these cities go across to all other cities as well. So what's happening in these cities can actually be in real time replicated across the country. And there are fundamental issues in the National Mission on Clean Air, or whether the topic that we are talking about, which is about measurement. And it's amazing the kind of technology and the kind of accuracy we can get with low-cost sensors. And I think, India has always been doing that. This is what I think, I often call in my deliberations as affordable excellence. It seems like an oxymoron, but something which is affordable cannot be excellent, and vice versa. But I think, technologies like this and the work that Professor Tripathi and his team and the 4 startups that have demonstrated exactly falls in this bracket of affordable excellence. Something I equate with the mobile phone, because a mobile phone is available with the richest of the richest and the poorest of the poor. It's an affordable yet excellent communication device. Why can't we create the various mobile? I think this is the mobile phone for for the environmental space, as I can see it. But there are fundamentally many other issues that need to be resolved. It's about giving the right set of right sort of autonomy and right fiscal and administrative freedom for cities to actually galvanize action, which is where I would like to, suggest that if Maharashtra has gone this distance, then Maharashtra should also look at possible ways of engineering action in cities around these results and deepening environmental debate, deepening the debate around air quality and deepening action around air quality. We shouldn't only stop at measurement, but actually go forward and support our cities in galvanizing action and support them in all ways, whether it is through administrative means or whether it is through fiscal and financial means to actually achieve the targets that are supposed to be achieved. And then I think, these technologies cannot remain to 4 startups or maybe, particular sensors. They have to explode in the country. We need many, many of these. So I think outcome level standards need to be created where, a certain outcome is standardized, and based on those outcomes, then we can go for multiple companies and, multiple startups and multiple different vendors who can deliver those outcome level standard equipment across the country. And so outcome standards will have to be created by the Ministry of Environment and Forest, CPCB, if they don't exist for this kind of work that you're doing. I may be wrong, but if that is the case, then our cities can just tender out outcome level standards saying this is the outcome we need, and sensors like this, if they are then certified by the relevant agencies in the country, have already been certified, then they can actually start getting deployed in many other cities, and the market will just explode. So I think the outcome level standard is very important, which is where CPCB and MOFCC needs to come up. And so I'll end here. I think I'll have to be brief. We are here to support such initiatives. We and my entire team at the mission, we are very focused on this sector. We want to create this action around climate as deeper and as wider as possible across the country. I think the efforts that have been taken, as have been visible in this call, will go a long way, provided we take the right decisions in the right directions, standardize things, and look at issues in a holistic manner and not only stop at measurement and move towards building action. So that's where I'll stop. Thank you.
Thanks very much, Mr. Kumar. I mean, time is very short, but I do have to ask you on how do you see the National Mission of Clean Air, the National Clean Air Plan, the Smart Cities Mission, be able to triage what will happen on clean air in India, and just a quick view on the implications of, creating a national mission on clean air. You said this will be, in some of the specific cities which are also non-attainment and big cities. Could you elaborate on that a bit further?
Yes, so the National Mission for Clean Air, in fact, is being, at the moment, I think it's in the draft stage with the MOFCC, and they have been taking comments from various sections. And once launched, it will be essentially for 1 million+ cities and all those cities which are non-attainment cities as per the clean air standards are concerned. And while we have a set of smart cities, and they may be the same cities, so we are actually trying to figure out a way of working in all the cities and trying to percolate the work of the smart cities mission in those cities and vice versa. And we're trying to club together and create synergies between the smart city plans and the National Mission of Clean Air plans, so that these cities work on a concerted, synergy agenda instead of working in silos. This is the current state of affairs. Of course, we'll also have to talk to the state governments. And as I said, they will have to support their cities and building this coherent action on ground, because it's all about creating the right teams at the level of the city who look at this data in real time, because that's all being possible by systems being developed, as we've seen on this call, and then take action forward. And for example, we just set up the Center for Climate for Cities, C-Cube, within NIUA. I don't know how many of you are aware. We are actually creating a whole organization within the National Institute of Urban Affairs focusing on climate. And we are now staffing it and giving it all the resources and appropriate capabilities to support this kind of work in the country. That, along with the state governments and the responsible actors in the cities. This is how we will have to go through it and create as many synergies as possible between the two missions.
Understood, right. We have to keep going, but this is really interesting and important. And you make that point about climate governance. I think that's for discussion on another panel, but ultimately the gains that will come on air quality and the gains that will come on going on low carbon pathways will not be distinct from each other, and the solutions will also be all together. So just that point on, how administratively and in the sense of creating that institutional framework to get it right. But I think that's where a lot of the cracking of the code will lie. Thanks so much for sharing these very important points, and hope to talk to you, sometime very soon. I'll keep going, but you also talked about how within the state, cities should be supported. And Dr. Modkare, I'm looking at you really, because there is enough that has happened in Maharashtra. This pilot in and of itself is only Mumbai, but about 18 cities sit as non-attainment within the National Clean Air Plan. And I wanted to hear from you, what your view is of this kind of a project, and do you think this is really the mobile phone so far for the environmental space, and is MPCB ready for scale up? Are you around, Dr. Modkare? Your mute button is still on. If you're trying, I will give it 10 more seconds. And if not, then time is short. We will try and come back. But Benjamin, let me move to you. I mean, Sudhir Srivastava said in the beginning that this is one of the most extensive networks that has been set up, but a lot has been done in other parts of the world, including the London Air Quality Network, which you have been quite involved in setting up. So any lessons to learn from there? How do you think the network really helped guide some of the policy-driven initiatives, and how things are looking different in London with this? And there was this famous and infamous Ella case, which all of us read here about, and at least to us, a lot of the air quality discussion in London and how it linked with people and how it linked with public health brought really close by the unfortunate death of that child. But over to you on how the conversations have developed, especially with the monitoring network.
Thank you very much, and thank you to the organisers. It's an honour to be part of this impressive project in your state. So I've been part of the London Air Quality Network since around 1995. And it's a long time to be working on air quality in one city, but I've certainly seen changes in that period. So the London Air Quality Network was set up as a reference network. And it did have all of those disadvantages that were mentioned right at the beginning, in that very expensive and involving a lot of work to keep them running. But what it does mean is that we've got a very long time series of data across the city to really evaluate the various actions that have been taken. And certainly in those 25 or so years, the level of public awareness of this issue has changed dramatically. And I think that's very important when we look at projects like this one in low-cost sensors. So the reference network is very much run by the local governance structure, overseen by the mayor, but it's the London boroughs who set up the monitoring networks, and we help them run them to that high standard and analyse and disseminate the data. There's been a number of mayoral level initiatives and national level initiatives, such as low emission zones, congestion charging, clean taxi initiatives, clean buses, etc. And these are very much done by the administering authority. We're now getting to the point in London where two things are happening. One, those initiatives are beginning to really impinge on people and the way they live. So if we're going to get these through the democratic process, they need to be supported by the public. And secondly, we're increasingly looking at changing the public's behaviour. So we're not just relying on technological change to improve air quality. We're trying to persuade people to purchase differently, travel around the city differently, heat their homes differently. And to do that, again, you need to get them on board, and you need to encourage them that this is something that they want to do. So this is something that a reference network cannot do because it's not dense enough. The Breathe London network is a sister network to the London Air Quality Network, comprising of low-cost sensors, and that's supported by the Mayor of London, but also supported by Bloomberg. And the aim of that is to put the air quality monitoring process into the hands of the public. So the public decide where these sensors go. The public decide what the data is going to be used for, and they get full access to the data. But it goes through our data processing systems. So the data that they're supplied with is high quality. We have a similar system to what was presented, but we use our reference monitoring network to provide real-time calibration and correction of the sensor network. So the two very much work together and work in tandem. But the important thing is that the public feels empowered by this new low-cost sensor network. And we're particularly interested in vulnerable communities and vulnerable neighborhoods. And they may be the ones that don't have the ability to stand up and have their voice heard. So we need to go into those communities ourselves and say, this is your environment, this is your community, here's an opportunity. We will give you an opportunity to look at the quality of your environment so that we can help formulate initiatives to improve your neighborhood's air quality. So there's a great deal of empowerment involved in that, and we're hoping that this will really trigger additional local initiatives within neighborhoods over and above those that are being done at the city scale and the national scale. So it's a kind of democratization of the data, but it has to be good data. And it's initiatives like the one presented here today that ensure that those data going out to the public are good data, are accurate. So there's a certain amount of control required on that data. So we see ourselves as a sort of control conduit for that system. So it's an exciting time. In the first 12 months, we started in January with this new network. In the first 4 or 5 months, we installed the first 100. And by the end of the year, we hope to have around 350 sensor node installed within the city, all of those having had input on their placement by the public.
Thanks very much, Benjamin. I mean, there is lots that you said there, but the one obvious thing that I've picked up was the democratization of data and how, this really offers a way for citizens to be empowered. We have seen bits and pieces of this, and surely there is a long way to go in building greater public understanding, but also just stronger public campaigns to demand for clean air. And that's, I think Dr. Modkar is also back. I'll come back to you, Dr. Modkar, but because, I wanted to just capture this point and also ask Chetan from where he sits, of course, as India's premier news channel, and his view on how the public really sees air quality as an issue, but pretty much also from a citizen perspective, and the fact that, do you think citizens at the neighborhood level can be empowered enough to demand this kind of a change in air quality? I mean, it's very different from how it can be in the UK and in other parts of the world, and in India, Chetan, our experience has been quite different, but yet a window of opportunity did get created. So what do you think, are the pros and cons, and where would you emphasize the next stage of the air quality campaign, so to speak, in terms of priorities and the democratization of this data?
Hi, Arti. Thanks for inviting me over. I think the citizen would really require and can use such data, which should be easily available, as many speakers earlier have pointed out, neighborhood data, and a lot more from a dense network of air monitors. I just want to make a couple of points. I think what the MPCB has achieved today through its leadership in this project is nothing short of a breakthrough moment in the air pollution crisis in India. This is a crisis where we're seeing something like 3 deaths every minute. And in the last 5-6 years that we began, that this area really exploded, the number of deaths has actually gone up. It was something like about 11 lakhs, 1.1 million in 2018, and then it shot up to about 1.6 million in 2019. So more and more people are getting affected. And this kind of breakthrough moment is not just because of what our scientists, our brilliant scientists in both the government and outside government have achieved, but also the buy-in from separate government agencies at both the state level and various central agencies. And I think that is that is critical, because now hopefully over the next year and a half, once the standardization and certification has been rolled out, and the official from CPCB mentioned that also, there should be an explosion of such networks, not just in Bombay and not just on trial basis. Roll it out in various cities, in many more cities, maybe 20, 30 cities, because at this cost, it's about 1/10 of the regulatory monitors. It should be quite easily doable. The other advantage is, of course, the economic advantage. Like I think the American ambassador had said last year that every $1 they invested into clean air technologies has yielded a return of $30 over a time period of about 4 to 5 decades. So I think it's really worthwhile to cash in on this moment. I know the entire economy is hurting, and we as a country are just still recovering from the trauma of COVID, and there might be more waves. But I think that has exposed us to just how much damage respiratory diseases can cause us. And so far, what we've been seeing over the last few years is that air quality, citizens' concerns about air quality is usually driven by the season. So in October, November, when it's really thick in our faces, that's when it hits the headlines. But I think a dense network and really this democratization of data would really help in sending the message out and in empowering the citizens. If they know if they're informed, they will also demand action and be able to take action themselves. Aarti?
Yes, thanks very much, Chetan. I'm a little bit nervous now because we're crossing the time, and I did want to have some kind of a discussion, but looks like time is very short. I mean, Dr. Modghare, before I try to just give my comments, I wanted to check, are you there? Because everybody is making that point that it's not just about using them as a pilot. This is about empowerment. And what's your view from how you have seen this? And I can see you now, so please, the floor is yours. We'll have to be really succinct, but may I request you to please share your views in 2-3 minutes, please.
Thank you. I'm audible, Aarti?
Yes, yes.
Yeah. So the whole idea was on this issue was initiated by Professor S.N. Tripathi and Honorable Chairman Sri Sudhir Srivastava, sir. And last year also we have taken some trials of these low-cost sensors. But now this is a 40 low-cost sensors we have tried in our Mumbai region. The Maharashtra is having a highest number of non-attainment cities, that is 18 non-attainment cities and 1 million plus cities. And with the macro planning is needed for the National Clean Air Program to monitor. The data from the sensors, these low-cost sensors, will really help us in tackling the hotspot technology, where the hotspots are there. Some of the things I want to mention is that the assessment is understanding the calibrations of the sensor is one of the main things. Performance evaluation, identification of the city level hotspot, and potential use of the sensor. 2-3 points I want to make is that these sensors cannot work independently without the conventional reference station. Therefore, its application for the compliance monitoring for the regulatory bodies need to be considered very carefully. Because when we assess the R value, it needs to be tackled, it needs to match with our CAQMS data. That is one thing. That also the technologists are working on that. The conventional stations like CAQMS give the real-time data, and it can be calibrated with the known concentration, which gives the more accurate value. That is the CAQMS, which is a known technology as approved by the ministry and CPCB. And also the yearly data required for further studies. Because this is a 6-month data we have taken. Sensor life is maybe more than, maybe around 1.5 years. And these performances get deteriorated once due to the humidity and temperature. This also things needs to be taken while considering the data. And recurring cost of the sensor is also thing. These are the, and more research and study is needed in the Indian conditions like temperature and humidity. So this hotspot identification is really will helpful in identification of with the data from the sensors. Really is a nice initiative from our Maharashtra Pollution Control Board. And sorry, I want to make announcement that the Maharashtra Pollution Control Board has been awarded as a ISO 27000 award today, and I was there in the function. So I could not join. This is the first board which is given the ISO 27000. So that's all from my side. Thank you, Aarti.
Thanks very much, Dr. Modkare. Many congratulations to you and Sudhir Srivastav, sir. MPCB, as always, has been quite on the forefront of doing progressive things, like we said in the beginning. It's already 5 minutes on top of the hour. I should not speak any further, but I do want to invite you, Professor Tripathi, once in the end, because you conceptualized all of this. There are views from a spectrum of experts, not just in India, but also Benjamin coming and speaking sharing his insights. How do you see the next stage, and how do you want to wrap this up, just in terms of the very positive feedback that has come, but some of the the concerns that still remain to be addressed on how this can be scaled up? And after your last word, we will end. Sorry for the questions that we've not been able to answer. Please feel free to reach out to the Prof, to any of the startups, or even to Gunjan or myself if you have any specific queries. And thanks very much, Priya, for all the initiative on this, and for Bloomberg Philanthropies to lead on this and bring this together. I'm just, as you see, giving my last word, because in the end, the Prof will have the last word and we will close after that.
Yeah, thank you, Aarti. I hope you can hear me. Well, I mean, I just want to make it clear. I think most of the things have been said. I mean, one has to understand that we are looking for, or one should be looking for, a hybrid approach. This reference or equivalent reference, these grade monitors are indispensable. Nobody's saying that you do away with that, right? It's very much, it needs to be there. But remember that if cities like London, New York, in California, Paris, if they are not able to meet, or in Beijing, you just look at the example of Beijing, the way they have swamped the city of Beijing and China with the sensors, right? So London has, if I'm not wrong, Professor Barrett is here, they have about 80 reference grade monitors, something like that, of that order, but they still bagged it up with sensors. So idea here is that you want to add sensors to have more data for getting more informed decisions. You want to empower citizens, right? Now, that cannot be done no matter how much resources you put only in the reference grade monitors. But if you have these sensors, I think you can do it. You can make the reference grade monitors mobile. That is the idea where we worked, or we are working on, that I showed you, that you can port these machine learning models, and these machine learning models are extremely powerful, and they are, every second they are becoming more powerful. So if you have even very, very small data in future, I'm talking about, if you have a reference grade monitors on the roll, you co-locate it for a day or 2 days in future, you will have sufficient data, and that's good enough for the sensors to start getting into that. And if you like to check, you can check now that US EPA, through their government website, is actually giving you 800 government monitors plus thousands of low-cost sensor data, all assimilated into one seamless data thing. And they are saying that this is not for regulatory purposes, but this is for many other applications what we have. The second point I want to say, and this is for everyone, for regulators and whoever is there, that you cannot buy horse in the price of sheep, right? So you have to see that the cost difference. But if you are looking for any kind of accreditation for these, like going to regulate, these kind of agencies, say NPL or something, that's not going in the right direction. You can never create a standard for these sensors. And again, I will quote you. You can go to other regulatory agencies who are well established. They are also not giving you any fixed standards for these sensors. So that's not the way we should go for that, right? The third thing, I think time is there. There's enough data, there's enough evidence that we should start using them. It should not happen that we use them, but it's already late. So that's all I would have to say here. Thank you.
Thanks very much, Prof. No need to recap on this. I see there are 2 hands. I'm sorry, I will have to let this go. We are 10 minutes on top of the hour, Dr. Dipankar Saha and Mr. Akash Rai, but feel free to reach out. You're all in the community. You will know everybody here quite well. So maybe I will end at the moment, and thanks everyone once again for joining. Thank you for all the participants who stayed over time, and have a very good weekend. Thanks.